Can you can you be able to hear me? Mr. Mamija. Okay. Okay, let's get started. So, we are introducing another concept, which is routing and routing protocols. And what you need to know about routing, what you need to know about this routing and routing protocols is that when you have a router, you're going to have, okay, let's say, for instance, this other link is connected to another router here. So let's talk about this one, this router. The moment this router receives data from from this one, let's say this one is A, this one is B, and then this one is C. So when B receives data from A, it will have to decide where to send the data. So let's say, for instance, there's another router here, and there's another one. This router B must be able to decide where to send the message. It must be able to decide where should I send the message for, for me to get the message delivered to the destination. That's all about routing. It has to make decisions. So where are those decisions taken? We're going to use the protocols. The protocols are the ones that will take decisions. So we have, you can see, very after the end of this lesson, Elena will be able to explain the significance of static routing. We have what we call static routing. We will be able to also configure the static and default routes. We'll also be able to verify and troubleshoot static and default routes. We will also discuss the classes of routing protocols. And also, we should discuss the distance vector routing protocols, or known as DVR. We'll discuss the link state routing protocols. We'll also describe the basic characteristics of the common routing protocols. Discuss the interior gateway protocols, and also discuss the exterior gateway protocols. We'll explain the processes of enable routing information protocol, or RIP, on a router. So under this routing, we actually classify routing with their types. We have types of routing. We have types of routings, or types of routing. Programmed route that a network administrator enters into the router. So we will actually understand more when we do the configuration for this static routing. It's very, very understandable when you are configuring it. That's why they even decide that they will allow you to configure it, or they will want you to configure it on this slide. We also have a dynamic routing that uses a route that a routing protocol adjusts automatically for topology or traffic changes. So this one you can see already it's going to be using the same IP address or the same route, but the dynamic one will change based on the network because the routing table never changes. Dynamic, the routing table will change. So here is how we configure the static routing. This is how we configure the static routing. You can see that we have this one. If you open your Cisco packet tracer, which I think we will do it in just a few minutes. So you will have IP route 172.16.1.0, then 255.255.255.0, then S0. You can see that this IP route is the command. Then 172.16.1.0 is our destination network. It's our destination network. You can see that we have a zero there. So it's standing for the network. It stands for the network. So here is the interface. I hope you can see it. So here they also have a command which is used to show the routing table. This is how to show the routing table. You can see that we have this as a routing table, and it's what we actually configure. It's what we actually configure. Okay. Then we also have to talk about the IP route command. IP route command, the one that we saw from the previous slide. They say IP route prefix mask address interfaces distance tag and permanent. So this is what you can actually put in after this command IP route. So you put IP route and then you write the prefix mask, which is you saw that you saw what is happening here, right? So Maran, yeah, it's IP route, then prefix mask, then interface, distance, so on and so on. Here now they are explaining what is the meaning of the prefix. Prefix. Prefix is the IP route prefix for the destination. Prefix. Okay, I thought it's prefix mark, but it's prefix, then mask, then address, then interface, then distance, then this tag, this permanent. You can see we have prefix, which is IP route prefix for the destination. You saw that we have destination here. We have the destination. We have the destination, which is this one. We have the destination IP address, which is that one. Okay, this is the destination IP address. So the destination IP, then the mask, then the address, what the mask, then what follows? Address interface. Yeah, it's this one, address interface. So this one, S0 is the interface. The interface that the, the packet will be sent to. You'll understand when we continue to the next slide. That we also have to specify the interface that we will send the packet to. It's called the outgoing. When a router receives a message, it must decide where to send the message. Then here we gave it the destination network, the subnet mask, and also the interface. We're telling it that we're using this interface. We're using this interface. So it's not even difficult to actually track this. We also have the address, the distance, which is optional. This one is optional. It's up to you. Just put it if you want to. It's not actually forced for you to write it. You are not forced to write this distance. It's optional. And we have permanent, which is also optional. The tag as well as optional. And now we look at an example of how to configure this static routing. The static routing. You can see that we have IP route, which is our command, then the destination network. You see from this diagram. You can see from this diagram that we have different networks. We have different networks. We have this one, 172.16.5.1. You see that we have this network, also have this one, and we also have this one. How do we identify the difference between these networks? Can you be able to see how to differentiate them? You can see that we have this one, you know,
I
this
can't see it anymore.
172.16.1. You can see.
Yes. I don't know what's happening. Um, okay. Can't see anymore.
You can't see anymore. What could be the problem? On my side, I can see it. Is it fine now?
I don't know what's happening. Let me check. Maybe it's my side. Let me refresh. Yeah, I can see now.
Yeah. So I was saying we have this network, we have this network, and this network. You can see that we have 172.16.1.1, right? It's this IP address. It's the IP address for this interface. So for this interface is 172.16.3.1. You can see that we have the difference there. And also for this one is 172.16.5.1. So the difference is here. So the network address for this one, you know it's going to be 172.16.1.0. You know how to find that. You know the network address must only start from zero. If you have dot one, it has to start from zero. And then 172.16.3.0 is for this one. And then another one for this one will be 172.16.5.0. This is the network address for this one. And then one is for this one. This one is for this one. Okay. So now they say IP route, then destination network, then 255.255.255.0, then S1. What what are they saying? IP route 172.16.1.0. Where is it? It's 1.0 with this network. It's this network, the university router. It has to have an interface. And I don't think they will use a wireless interface. I don't think so. I don't think it's possible. Unless if it will be using what? Another type of uh, another type of frequency, which is supposed to be a very high frequency. Probably, I don't know. But most probably it's going to be wired. You will have an interface connected to this, which is a wire. An interface is just a cable, any cable that is connected to a, a network device. It's called an interface. It's called an interface. So this S1, you can see here, they said it's your interface. You're indicating that it will use this interface, and the destination network is what is this one for dot zero. It means it's going to where some of one of the computers is going to one of the computers. That's what we're sure of. That is going to this network, probably to one of these computers. That's the static routing. And then again, we have IP route 172.16.5.0. What does it mean now? We are talking about this one, the 5.0. It means this routing table is for this one. It's for this one, right? You can see now that we are configuring this one. We have the destination interface as S0. That's why it has to be S0 because this is where it's connected. This is the interface S0. It's actually also very understandable with the Cisco Packet Tracer. So here we have IP route destination network, which is 16.1.0, and then the subnet mask, then the gateway. Now, we talked of an interface, right? I told you that here it was this, but the interface that we were talking about, it is actually having an IP address. It must have an IP address. Each and every interface in a network device, it must have an IP address. You can see here that it says IP route 172.16.1.0, which is the one from previous Okay. So yeah, as I was saying that the interface here as well, it must have an IP address. So here they wrote gateway instead of interface. So instead of that, you can, instead of the interface, they wrote a gateway router. The route. The route will not be installed in the routing table. table. So when you actually configure this static routing, you that at first the route as zero. Yeah, they were just they were just placing this for an interface, but you don't actually write the interface here. You have to write the default gateway address, the default gateway IP address. That's the routing interface. That is why they wrote an interface here. Okay. Now here they are showing the routing table. Show IP route. This command is to show the routing table. But we have S for just meaning static, then C for connected. We are connected to 192.168.2.0/24, and also the route. This one is for routing. It's for the router. It's for the when we receive a packet, we can route it to this other network. It's what we configure. It's what we configure for Hoboken. You can see that we have this router for Hoboken. Okay. But the cost for all static routes is 0. Okay. I didn't know about that. And okay. So one administrative distance is actually something that we have route source, we have default distance values. Here under route source, we have connected interface 0, which is our distance values. Then static route is 1, very enhanced interior gateway routing protocol or EIGRP. Its summary route is 5. Then external border gateway protocol or BGP is it's going to be 20. Then internal EIGRP, but the IGRP is 100. The OSPF. So yeah, but the administrative distance is the trustworthiness of the routing information. Administrative distance is the trustworthiness. But if, the lower the administrative distance, the more trustworthy the information. Okay, let's hope we'll understand this as this. This the network which is, mean, this is the router that is saying. So when we consider route, route, we are actually telling it how to reach network on those networks, how to actually reach computer inside that network. That's when you are routing. You're telling a router how to reach a certain network or how to reach the devices inside that network. So you can see that we have scaling router and also Waycross, and there's also Hoboken. The Hoboken router is the one that is being told that they can reach Sterling and they can reach Waycross routers. So this is how it was told by saying IP route 172.16.1.0. We are telling it how to reach those networks. We're telling the router how to reach those networks. I hope you can see it. And then the subnet mask, all of them are using the same subnet mask. So we cannot tell which subnet mask is this for. But the interface is going to be replaced by the IP address of the next hop or way. This S1 and this S0 will be replaced by what you call default gateway. But two choices. How do they differ? We have this one and also this one. But this command points to Sterling, to the Sterling line. But this command points to the Waycross line. And how are these different? Very you can write S1, and so you can write 172.16.2.1. Okay, these are uh, uh, two strategies that you can use according to what they're saying here. So it means here at S1, here you used the interface number S1 or S0. Here you used an IP address for the next hop. How do they differ? How do they differ? That's what they're asking. Then now we have another example, RTZ and RTY. We are at RTZ. You can see here, RTZ config. RTZ config. We have IP route 22.24.4.0, 255.255.255.0, then 172.16.1.2. That's our, it's this one, it's this example. It's this example, the one for putting an IP address instead of an interface. So we are on the RTZ router. then we type IP route 172.24.4.0. So I think we can actually try and configure a router. Try configure a router statically. Let me just try. Just so 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 we have two routers. Uh, in that case, let's have three of them. Let's have three of them. Control C. Control V. So I'm just gonna have similar example to what we have on the. Okay, let me see if the device not out or and then from there you will you will go to yeah config and then this routing. You can see the routing. Then the static is RIP or uh, default. I mean the static and the other one dynamic. So this static one, we have to put the network. We have to put the network, which is the network of where the packet is going. So it means before we can configure the routers or the routers, you must actually use the IP address. So I'm going to say because we also have must also have computers there. Must also have computers because it's not going to be possible without computers. You will need a computer the switch. Also here, also here. Depend on the document. We use the same addresses. We have 172.16.2.1 and we have 16, we have 1, we have 16.1, 16.3, 16.5. So 172, 172, 16.1.